Hello, and welcome back to this amazing channel. This is Abhinav. Today, in this particular video, we'll discuss about all the 4 problems of Leetcode Weekly Contest 412. Yeah, the contest was I will say on a little or difficult level. The first 2 problems were very basic, very brute force problem, but the second 2 problems were of a really hard level, right? So let's discuss all the problems, all the 4 problems of this contest one by one. Let's start with the very first problem, which is actually a very brute force problem. Problem says that final array state after k multiplication operation. This is the first version of this problem, and we have second version of this problem also, which is the third problem. So we'll discuss both of them. Okay. The problem says that you are given an integer array nums and an integer k and an integer multiplier. Okay. Now what you can do is you have to perform k operations on this array nums. And what are that k operations are? In each operation, you will find the minimum value of x, means the minimum value in the whole nums array, and then you will multiply that value x with x into the multiplier which is given to you. And this you have to apply k times. You have to apply k operations of this on that nums. That is what is given to you. Right. So if you will see here, you have to just k times get the minimum value from the array and then multiply this multiplier in the element, in that particular minimum element. And that is what the problem is. And if you will see here, the constants and the length of the array is just up to 100 and k is just up to 10. That means we can apply proper brute force solution here, which is I have also did. So what I did is I am just going through the whole array, okay, finding the minimum element, the index of the minimum element that in the whole array, which is the index of the minimum element, and then I am multiplying that particular element with the multiplier. And I'm repeating this thing how many times? K number of times, because we have to do k operations. This is a very basic thing that I am doing in this first particular problem, right? If you will see, the time complex will be n into k only, and because the constants of n and k are very low, this time complexity will work. And this is how we are solving this first particular problem. I hope that you have got the understanding of this particular problem. Okay. Second, part of this problem, which is I will say a harder problem, very hard in this. That is the third problem. We will discuss it later in the video, right? But I hope that this is clear to you. So as I again tell you, the time complexity for this problem is just order of n into k, and space complexity is constant. I'm not taking any extra space, right? For this first problem. Amazing. Now let's move to the next problem, which is count almost equal pairs 1. So this is a problem which is a easier one than its second version, obviously. Still, it's a little of, you can say, a medium level problem. What the problem is that you are given an array nums consisting of positive integers. So you have, again here you have a array of some numbers, of some integers, and what you do is they are saying two elements, two integers x and y are called almost equal. They are called almost equal if both integers can become equal after performing the following operation. What operation? So basically what you can do, if there are two numbers and in one of the two number, if you will swap two digits, and if the number will become equal, that means they are almost equal. Not equal, they're almost equal. Let me give you an example. For example, the first number is like this, 516383, and second number is, let's say, 5381. So if you will see, if you will just swap these two numbers, it will also become 5183, means they will become equal. So means if swapping two numbers will, if swapping two digits of a number will make both the numbers equal, that means they are almost equal. We call them as almost equal. And also, it is not a compulsory that you have to do this swap. At most one you can do. You can also, if even the numbers are already equal like this, then they are also again almost equal, right? And you have to also handle the trailing zeros, right? Not trailing zeros, front zero, right? For example, let's say number A is 3 and number B is 30. It's still they're almost equal. How? Because you will consider this 3 as 03, and when you will swap this, you can see it will also become 03, right? So they will become equal. So they are also almost equal. So you have to basically handle this zeros also in the start, right? Amazing. How I'm solving this problem? I'm simply solving this problem with the brute force approach. Why brute force, guys? Because we will see here also, the length of the nums is just up to 100. Is just up to 100. right? Means the array will contain only 100 elements, and each element is also of just up to 10 to the power 6. That means will just contain 6 digits. Why I'm considering this, I will tell you. Okay, so what I'm doing is that here they're asking us all the pairs. We have to return all the pairs or all the number of indices which are almost equal. Okay, so what I will do, I'm first of all, you will see I'm checking for every index. So using a brute force approach, I'm first having a loop of I, then I'm having a loop of j. Up j is starting from I plus 1, because here they are saying that j should be greater than I. You should not take duplicate basically. So here for every I and j, I'm checking that whether they are almost equal or not. And for finding if they're almost equal, I've written a function called is almost equal. Is almost equal. And using this function, I'm checking whether this nums I and nums j are almost equal or not. How to check what this function is doing? Let me tell you. So in this function is almost equal, what I'm doing, simple. I have to do nothing. I'm just checking that at what indexes the number are different, the digits are different. And wherever they are different, I'm storing it in a vector of pair. Let me give you an example. For example, this same A and B are case, okay? So what I'm doing is, what I'm doing in this case, A and B, I'm taking, you can see, while A is greater than 0 or B is greater than 0, I'm taking the last digit of the number and then I'm dividing it by 10 if it is not 0. For example, from here, the digit will come, RA will come at 3. Here, the RB will come as 1. Means the last digit here and here are not equal. So if they are not equal, that means they need to be swapped somewhere to make them equal. So what I will do, in a vector of pair, I will add this 3 and 1. Okay, amazing. Now next you can see this 8 and 8 are equal. So if they are equal, no worry, move forward. Again there you can see not equal, 1 and 3 is there. So again I will insert this 1 and 3 here. And then again they are equal. So you can see there should be at least two non-equal indices. See, either there are all indices are equal. Let's say A is 1, 2, 3 and B is 1, 2, 3. Then it's fine. But if the case will come like this, let's say A is 1, 4, 3 and B is 1, 2, 3. They are not almost equal. Why? Because here you cannot do any swap. You cannot do any swap. There is only one index which is not equal. So number of non-equal indexes should be only 2, not more than 2 or not even less than 2, means not even 1. Either 0, either 2. So if the number of non-equal indexes are either 0 or either 2, then only the answer is possible. Right. तो अब देखो यहाँ पे क्या कर रहे हैं हम लोग कि हम first taking all the digits of the number A and B. If a digit is not equal, I'm inserting it inside the priority queue. Not priority, sorry, vector of pair. And if the size of the vector of pair becomes more than, okay, I'm saying equal to, so even equal to, because here I'm adding one more number. If you feel difficulty here, I can write like this. So if the vector pair size becomes more than 2, that more than 2 indexes are not equal. That means we cannot make them equal by just having a swap. Answer will be false. Also at the last time checking that if vector pair size is 1 or greater than 2. 1, why 1? Because if there is only one index whose digits are not equal, if there is only one index whose digits are not equal, again the same problem then. The problem will be what? That you cannot make them equal by swapping. If this is 0, means there is no digit which are not equal. All digits are already equal. Then answer is obviously true. Now, when there is only 2 digits which are equal, when there are only 2 digits which are equal, then what I am doing? See, when there are just 2 digits, let's say here it was 1 and 3, here it was 3 and 1, like this. That means they should be equal like this. Means in this first vector, first index, second element is equal to the second vector first, and like this. Then only after swapping we can make them equal. So what I'm checking is that VP0 first should be equal to VP1 second, and VP1 first should be equal to VP0 second. If this both the cases are true, I will return true, else I will return false. Right? So this is a very basic approach where for every pair, I'm checking whether they are almost equal or not. And to check almost equal, this is what we are doing. Right? So guys, this is how we are solving this particular problem, which is count almost equal pairs 1. Right? This is the first version of this problem. Now let's discuss the next two problems of this particular contest, which are the second versions of the previous two problems that we discussed and which are on a higher level. Let's discuss that. By the way, for this particular problem, if you will see the time complexity and space complexity, so there is no as such space complexity. Okay, we have a space complexity here, which will be at most 2 only. So we will take it as a constant only. But if you will see space complexity, it's just order of n square because we are checking for every pair. Okay, now let's move to the next problems. So now let's discuss this third problem, which is final array state after k multiplication operations, right? This is the second version of the previous first problem, if you will see here. Okay, where we have to find the minimum element from the array and then you have to multiply it with the multiplier, and this we have to do k times. Similar thing is given here. There are only two major differences. The first thing is that here the constants are very high. There if you will see, the value of k was just up to 10, number array was just up to 100 size. Here the size of the array is up to 10 to the power 4, which is even fine, but the value of k is up to 10 to the power 9. This is the most complex part where we will have problem. I will tell you how. Okay, and plus here, because the value of k is very large, means after multiplying the multiplier, and the multiplier is also up to 10 to the power 6. Okay, so this multiplying the same number again by this multiplier may have a very large value. So we have to also apply the modulo, and this modulo they are asking us to apply at the end of all the k operations. Means we have to handle in that case. By the way, that will not make much difference, but yeah, it will be little complex in our usual problem. So the first thing that comes in our mind after seeing this problem is priority queue. Why priority queue? Because what we have to do here, we have to find the minimum value in the current whole array, and then from in that minimum value we will multiply with the multiplier, and then again we will push that value in the priority queue. Yahi karoge na? You will take a priority queue, you will take the minimum value from the priority queue, you will multiply it with the multiplier, and then you will again push it back, and you will repeat this operation how many times? K number of times. So overall time complexity will be k log n, if you will see. But even we cannot write a solution of k log n. Why? Because the value of k is very large. As I said you, this is what will make your problem complex. If the value of k was less, let's say it's 10 power 5 or 6, then you can easily apply priority queue solution here. Still we are using priority queue, but not directly priority queue. Now we are making a little complex to handle this k, because we cannot apply that priority queue operation k times. No, still the logic is somehow that only, that you will take the minimum element, we will multiply with the multiplier, and you will again push it back, and so on. But now it is little different. Okay, we are optimizing it more because we cannot do that k number of times. So how we are optimizing it, what we are doing, let me explain you. Okay, let me explain you. See, first of all, one thing, what we need to do is, if we can know that how these k operations will be distributed in the indexes. Let me give you an example. For example, my array is like this. So I am not taking very large number, so mod ka abhi nahi rakhte hain. Mod, when there are large number, we have to apply mod. That adds, okay, that's it. Still the problem will be as it is, right? There will not be any change in the logic if there's mod or there's no mod, right? So what we will do, let's say we have 5, 1, 2, 15, 6, let's say, okay, and our multiplier is, let's say, 3, and our k is, let's say, 100. Okay, first thing is that you will one by one choose the minimum value, let's say 1, multiply 3, okay, then again choose the next minimum value, multiply 3, and so on. This will be complex. Okay, why it will be complex? Because obviously when we will apply this particular thing, it will take k operations, and k is very large. Here it is 100, but it will be very large. So see, what we will do, we will get to know okay, if there are 100 operations, how many operations will be applied in the first index? Let's say 100 operation है, तो मैंने कहा let's say first यहाँ पर x1 operations होंगे, यहाँ पर x2 operations, x3 operations, x4 operations, x5 operations, and total of this all the operations 100 only. But how to know in each index how many multiplication will be there? How many multiplication each index will be there? We can't know that. And it will not be equal. Don't think that there will be equal number of multiplications in all the indexes. So we can just say, okay, k by 5, k by 5, k by 5, and so on. No, we cannot do that. So how we can do that? How can we do that? Let me tell you how can we do that. So basically what we can do here is that I will first try to apply these operations, this multiplication operation on this array until all the elements of this array are equal. Even maybe not, so they will not become exactly equal, but they will become equal such that now after performance they will become close to the maximum number. So you can see in this whole array your maximum number is 15, and there are some numbers which are very less than 15, so there will be no number more than 15, but all other numbers are less than 15. Some are very less, some are little less. So first of all I will try to make all these numbers close to 15. What? Close to 15, so that they should also not exceed 15 and they should also not become very less than 15, maybe just one multiplication away from the 15. Okay, let's say make it 25. It will be easy for me to explain. Okay, like this. 25 is the maximum. Okay. Up see, when 25 is the maximum, let's see how the multiplication will go on. So first we will multiply this 1 with 3, it will become 3. Okay. Next we will do here 6. Okay. Next 9, because multiplication is 3, right? 3 से multiply करेंगे. Next 15. Okay. Next, which is the smallest? This one. So 24. 6 is 18, sorry, 18. Then this one, 27. See, when I will multiply this 9 with 27, it will become more than this multiplication. So it should not go more than that. It should not multiplication with this maximum value. So this number should be within the range of the maximum value. By the way, now I will take 6. I will not take 9. Sorry, it will become 18. Now if you will see, if you will multiply this 3 with any of the number, it will become more than the maximum value. So our maximum value is 25. If you will multiply this 9 with 3, it will become 27. So you will not make your value, more than that, but it should be at least close enough to the maximum value. क्योंकि अब आप जितने मल्टीप्लिकेशन करोगे अब वो एक्स्ट्रा हो जाएंगे देन योर मैक्सिमम वैल्यू. सो यू शुड नॉट एक्सीड द मैक्सिमम वैल्यू. यू शुड बी विद इन द लिमिट ऑफ द मैक्सिमम वैल्यू. And now if you will see, so now you can see how many operations are done. So 1, 2, 3, 4, 5, 6. 6 operations are done. Oh, sorry. 6 operations are done. Still 94 operations are required. Now these 94 operations will be equally distributed. Why? Because all the values are close to each other. You will see. Still you will say, Abhinav, how we can distribute 94 equally, because 94 is not divisible by 5. We have 5 numbers. तो हाँ 90 को तो आप कर सकते, 90 अगर होते तो आप 18 18 18 you will distribute to every index. But what about that extra 4? So again that extra 4 operations will be given one by one to all the top 4 numbers. तो जो टॉप की 4 बचेंगे ना, जो मॉडुलस ऑफ k है वो एक्स्ट्रा जाएंगे, जो भी टॉप की 4 मिनिमम वैल्यूज आएंगी. Whatever top 4 minimum values will come, there that top 4 extra operations will go, and remaining 90 will be distributed equally amongst 5, because now they are close to each other. This is the logic. Okay. So let me tell you how we have done the let me so these 4 क्या होंगे, इस 4 का क्या होगा कि first it will go to here 27, then it will go to here, it will make it 45 here, so 18 into 3 54. Now these 4 are also done. Now remaining 90 operations, if you will see, it will be equally distributed to all 5. And let me show you how, because that cycle will go on. How? First 25, okay, then 27, then 45, then this, again 50, again 54, again 90, again this, again 100, again this, again this. So if you are saying now this cycle is going on, once they all became at the same level, after that this cycle will go on and remaining operation will be distributed equally to all the 5 or whatever indexes are present. Are you getting? अब वो cycle बनती रहेगी. But you have to just check the initial sum operations to make them on a same level, not equal, on a same level. Are you getting or not? Are you getting or not? Now let me show you how this thing we're implementing in our code. How this thing we're implementing in our code. Let me show you. तो ऐसे था हमारे पास, ठीक है. तो what I am doing is that in my code, if you will see, हाँ, first of all, if the multiplication value is 1, then obviously after performing k operations there will be no change in the values. वैल्यू वही रहेंगी, राइट, कोई चेंज नहीं होगा उनमें, ठीक है. तो इट विल बी नम्स ओनली. नाउ व्हाट आई एम डूइंग, आई एम मूविंग वन बाय वन. सो फर्स्ट ऑफ ऑल व्हाट आई डिड, आई हैव टेकन अ मैक्सिमम एलिमेंट, ठीक है, मैक्सिमम एलिमेंट, and which is in our case it is 25. Okay, now I'm taking a priority queue of min heap. Min heap means it will tell us the minimum number first, and also minimum number, if two numbers are equal, it will give me the number with the minimum index. That is what also they are saying, that if two numbers are equal, take the number first present. So that will be handled by priority queue, right? अब देखो यहाँ पर क्या हो रहा है, यहाँ पर they are saying that while k and while the value of the top value of priority queue into multiplication is less than mx, means until multiplying the minimum value with the multiplication is less than equal to mx, you have to multiply. For example, इस चीज के लिए क्या होगा कि it will be inside the priority queue like this. So it will be like this: first 1,1, then 2,2, then 5,0, number and its index 6,4, 25,3. तो पहले 1 आएगा, तो 1 में 3 का मल्टीप्लाई हुआ, इट विल बिकम 3, देन 2 विल बिकम 6, देन 3 विल बिकम 9, देन 5 विल बिकम 15, then 6 will become 18, then 6 will become 18. Now you can see you cannot do any more operation. So that much number of time, whatever operations are done, 6 operations are done, 6 time k will be decreased, and these operations will be done and added in the priority queue, right? And obviously we are taking mod. Okay, we are taking mod. इतना हम लोग कर रहे हैं, इतना हम लोग कर रहे हैं, right? So if you will see here that this much number of operations will be done. Once this is done, once they are on the same level, now we will see the remaining operation. Remaining k कितना है? 96. So 94. अब in this 94 also, if k is not divisible by n, which is 5, जब तक divisible नहीं तब तक again आप वो जो क्या करोगे कि you will take that numbers and you will multiply with the top के जितना भी है 4 numbers which are not greater. तो अब देखो यहाँ पे हम लोग क्या कर रहे हैं कि now I am going through all the elements of the priority queue. I am taking the first value, which is the value, then taking the second value, which is the index, I'm taking both the value and the index. Okay. Okay, yeah. I thought there's no pop. Yeah, we have popped here. I thought we're just pushing, we are not popping it. Yeah, pop was there. We are popping it also, right? Now you can see that if the k is modulus n, matlab if k modulus n is not equal to 0, means it is not divisible by n. So if it is not divisible by n, that means in the smallest value we have to do one extra operation. तो अब देखो हमने इनिशियली ये पाव निकाल रखा. What is this POW? So this POW is actually k by n we can say like this. This pow is actually multiplication to the power k by n modulus mod. Of why I am doing this, why we are finding it? We are finding it because, as I said, if there are 94 operations remaining, if k is 94, if there are 94 operations remaining, so 94 by 5, which is n, will be 18. Take integer only for now, will be 18. Means these 18 operations will be distributed equally amongst all the answers. Will be distributed equally among all the answers. And again, if you will do it in a brute force manner, if you will do 18 times multiplication of mul in all the values, it will be again TLE. So what I'm doing, first of all, I will find the value of 3 to the power 18 mod, whatever mod is given. इसकी निकालेंगे value, and then this power value I will multiply to all the numbers one by one. कुछ यही करना ना, हमें हमें क्या करना है, we have to multiply 318 times. So first I found the value of 3 power 18 mod, and then I will multiply it with this all the indexes. So अब देखो, I'm going through all the indexes in the priority queue, all the indexes in the priority queue, and at all the indexes I'm multiplying my value, the current value of the index, the current value of the index with the power, and obviously we're taking mod, and then whatever the final value I'm assigning to my index. And if you will see here, this 4 was remaining, this k modulus n, which was 4, it was remaining. Now those 4 will be distributed to the top 4 elements. So you can see जो भी top के 4 elements आएंगे, the top के k modulus n elements आएंगे, whatever top k modulus n elements will come in the priority queue, means which is smaller, तो उनमें हम क्या करेंगे, देयर वी आर मल्टीप्लाइंग वन एक्स्ट्रा multiplication, we are multiplying one extra multiplier along with power. You can see we are also multiplying one multiplier, and then we are decreasing k. Why? Because in that top 4 जो भी होंगे उसमें हमें एक्स्ट्रा 4 जो मॉडुलस है वो भी मल्टीप्लाई करना है साथ में. दैट एक्स्ट्रा मॉडुलस वैल्यू यू हैव टू मल्टीप्लाई टू द टॉप k modulus n values, indexes we can say. So there we are, along with power we are also multiplying this multiplier, right? And you can see this is the simple mod power function, and how we can find the value of a to the power b with modulus. You can get this anywhere easily. Okay, this is a very basic code of modular exponentiation. So yeah, this is how, guys, we are solving this particular problem called get final state. Get final state, right? If you see the time complexity of this, so see, first of all, priority queue will take n log n, because we are inserting all the values and it is sorted. It will take n log n, and if you will see, it's n log n only, because here it will be k, but it will just multiply up to the value is less than equal to maximum, up to that only. So we can say maximum value divided by multiplication, we can say in that way, and maximum value is just up to 10 power 9, and divide by multiplication we are doing, and also up to k, so it will be not go more than that only. Are you getting? Let's say if the values are let's say 10, maximum is 1000, so how many multiplication will go? Because we are not adding multiplication, we are multiplying multiplication. So even if the multiplication value is very low, let's say it's just 2, and let's say if the maximum value is 10 to the power 9, let's say, of our array, and our multiplication is minimum possible 2, so in the worst case also this loop will take order of 10 to the power 9 square root, means around 10 to the power 5 operation. If even multiplication value is just 2, let's say, and minimum value of the array is 1, maximum is 10 to the power 9, then also it will take 10 to the power 5 kind of operation. So means it will not go above that, right? And that is why we are having this particular problem. So yeah, time complexity is just, I will say, around I will say 10 to the power 6 or something, if you will see. But space complexity is also order of n, because of priority queue. Okay, so guys, this is how I'm solving this particular problem. If you still have any doubt, you can ask that to me in the comment section, or you can join Telegram channel to ask your doubt. Thank you. Now let's move to the next problem and the last problem of this particular video. So now finally discuss the last problem for this particular video, which is count almost equal pairs double, right? Second version. So this problem is again similar to the second problem of this contest, which is this one, but there are two major changes here. The first change is that we are having constants more, obviously. There the length of nums was very less. Here it is up to 10 power 5000. Oh, sorry, up to 5000. And not just that, in the first version, we were saying that we can only perform that swap operation once. But here we can perform that swap operation twice. दो बार हम लोग perform कर सकते हैं. At most twice, like either 0, 1 or 2. Not more than 2 basically. Okay, it's not like always 2 operations, but yeah, all at most 2 operations, right? Amazing. And now what the problem was? You have to find number of pairs which are almost equal. Means if we will perform at most 2 swaps operations in the digits of the number, and if they became equal, that means they are almost equal. That means they are almost equal, right? Up guys, this problem we are solving in a very brute force manner. You will say, Abhinav, how brute force will work? Yes, it will work. Why it will work? Because you can see the value of n is just 5000, just 5000. That means we can actually have an order of n square time complexity. And yeah, we are solving it using n square time complexity, not more than that. Okay, I understand more than n square will not work. Just like we are doing it in the first way, the first that will not work here. Okay, but yeah, n square can actually work. N square can actually work. Let me show you how. So see how we can find this pair. Let me give you an example. So if you will take some example, for example, ये ले लेते हैं, ठीक है. इसमें I will add one more digit, let's say 4, just to tell you some logic. Let's say if these are the four numbers, in our array, and you have to see which two pairs are almost equal, right? So they have actually told that these four pairs are equal. Let me also take that so that we can know which are almost equal. Array, it's taking very large. Huh. So you will see, according to them, to 1023 and 2310. Yeah, these are actually almost equal. How? Because if you will swap these, I think, okay, you want 0 here and 3 here. So if you will swap these two and these two, it will become 0213. Sorry, 1203. Yeah, it will become equal to this. Okay, but how we can do it? So first of all, guys, the logic is that, because see here we have to also take the zeros at the front of a number. So what I will do, first of all, I will consider in that way. तो मैं क्या करूँगा, I will take it like 1023, 2310, 2130, 0213 and 0004. अब देखो आप, सीधी सी बात है, the basic thing is that कि we can perform two swaps in a particular number. We can perform two swaps, at most two swaps. ठीक है. If we have to perform at most two swaps, how many different kind of numbers are possible? And if those numbers are present previously in the array, that means a pair is possible. Let me show you an example. For example, हमारा number है 2130. Let's say that we have 2130. अब if we have 2130, then how many different numbers are possible with this 2130? Can we find that? Yes, we can find that. Check by swapping all the digits. पहले इन दोनों को swap करो. When you will swap these two, it will become 1230. These two, it will become 3120. These two, it will become 20213. Now let's check for swapping these two. These two, it will become 2310. These two, it will become 2031. These two, it will become 2103. So basically, if the number contains n digits, I think n into n plus 1 by 2 different cases are possible. Okay, not n plus 1 by 2. Okay, this is the thing. N into n plus 1 by 2 different possible combinations are possible if you will swap. And this is just one swap. Sorry, this is just one swap. You can do one more swap ना, आप एक और swap कर सकते हो. तो इनमें एक और तो सिर्फ एक swap से हुआ ना. But let's say you need two swaps. तो इसमें एक और swap होगा. Let's say for this 1230 also, what is there? First check for this. So it will become 2130. Then one more. Okay, 2130. Then this two also. So 3210. Then these two. So 0231 and so on. So if यहाँ पर let's say if n into this is possible, one more is there. So basically if you will see, n to the power 4 different combinations are possible. You will say it is very large, but what is n? N is the number of digits in the number. Number of digits. And if you see the range of the numbers, range of number is just up to 10 to the power 7, less than 10 to the power 7. So if it is less than 10 to the power 7, that means it will just contain at most 7 digits. And value of 7 to the power 4 is nothing. It is nothing. It is just some 2401. So if number of digits in a number are just up to 7, we can easily perform this thing. We can easily done this thing. क्या दिक्कत है? So what I'm doing first of all, what I will do first of all, that for every number I will find that what are the different possible combinations of that number are possible after making two swaps. And how we can find that? Using this function called make swap changes. So this make swap changes is taking the number and digit. What is digits? So guys, digits is basically the digit of the maximum number in the array. So if you will see in this array, the maximum number was 2310. And how many digits are there? There are 4 digits. So I will make my digits equal to 4. So what I will do, every number I will first make of 4 digits before making any changes. Obviously, just like here I added 10, here I added 30. तो हर नंबर को हम पहले 4 डिजिट कर लेंगे. For that, I have a function called make digit. This function simply take the number, convert it into string, and then it adds some number of zeros. How many zeros? Whatever digits maximum number has. Let's say maximum number has 4 digit. This only has 3 digit. It will add 1 0, and then it returns the number in the form of a string. So what will happen? When I will pass some number in this make swap changes with the number of digits in the maximum number, let's say मैंने इसको pass किया 213 को, so it will make it 0213 in form of string. Now what it will do? Now it will first make a loop starting from 0 to I plus 1, like two different loops. Sorry, first for I and second for j. This will take the first swap. Let's say I आपका यहाँ पर है और j आपका यहाँ पर है. So you have swapped these both the values 1 2 0 3. And see guys, this is also a possible outcome because it is not saying that you should always perform two swaps. One swap is also possible. This is also a possible string after swapping. So you can see whatever possible strings are there, I'm inserting it inside this pause unordered set, where string itself is also present because वो भी एक possible है ना. हमने एक बार swap किया, I've inserted inside the pause. Now I will check for second swap. There's a second swap I am doing here. So after second swap, it will become 1302. So now for second swap, again I am taking a loop of digit to digit. And if the values are not equal, we are again swapping it, and again we are inserting inside the position. Again I am inserting inside the position. And then I am backtracking also because once a swap is done, I have to again re-swap it to make the string as it is. हर iteration में ऐसा नहीं कि बस swap करते जाओ. You have to again make the same changes. So first I took I and j and I swapped digits there. Then I am checking for I1 and j1. Second swap, I swapped digit there also. So now two swaps are done. I1 j1. Once both are done, inserted inside the possible set. Again re-swap. Again फिर से I1 j1 and ij again swap it so that the string becomes same. And by doing this, I will find all the possible strings which are possible for a particular number. इसके लिए ये possible होगा, ये होगा. Then multiple others are there. Let's say this also is there, and so on. जितने भी होंगे, whatever. And this will take just up to order of d to the power 4. What is d? D is the number of digit, which is very low, which is just 7. This is, I will say, even a constant function. You are taking there 4 loops, but the 4 loops are just running up to d to the power 4 times, where d is just 7. तो बहुत complexity नहीं है यहाँ. Main thing will come here. Now what I am doing is that for every number starting from 0 to n, I am finding all its possible strings after changes, after swapping. तो हर नंबर के लिए उसे कितनी पॉसिबल स्ट्रिंग है. लेट मी गिव यू एग्जांपल. जैसे कि फॉर दिस नंबर वन ऑफ द पॉसिबल स्ट्रिंग इज 20132. वन पॉसिबल स्ट्रिंग इज 2310. वन पॉसिबल स्ट्रिंग इज 3120 and so on. So all the possible strings we are getting. And now if that possible string which we are getting from by applying this swapping on this ith integer, if that string is present before, that means we got a pair. For example, आप देखो ये 2310 पहले present है, that means one pair we got. अगर दो बार present होता means 2 pairs we got. But how we can know that whether it is present before? For that I am taking an unordered map. So what I am doing ultimately, the summation of this problem is that I am going through all the particular indexes one by one. For each string, I am finding all its possible combination after swapping. Now I'm checking whether any of the possible combination is present before, because if it is present before, it will make a pair that we want. And how we can check if it is present before? So for every string which we are getting, using this make digit function, I'm making its MP plus plus. For example, यहाँ पर when we will go here, before it, MP of 1023 will be plus plus, will be equal to 1, and MP of 2310 will also equal to 1. So when this string will have a possible outcome this, it will say okay, yes, 2310 is already present, and then it will increase that in the answer. And then for that particular string also, MP will increase. So now MP of this 2130 will also increase. This is a kind of a basic greedy problem. Okay, and this is how guys we are solving it. So overall time complexity is just up to order of n square only, because this will take order of n square, order of n, and this set size will also be max order of n only, because this is just order of d to the power 4, where d is very small. It will not make any sense. Same here, order of d only, right? So guys, this is how we are solving this particular problem. I hope that you've got the understanding of this particular problem. Still, if you have any doubt, you can ask that to me in the comment section, or you can join Telegram channel to ask your doubt. Thank you for watching this particular video. See you in the next video. Thank you.